Okay, today we are doing section 9.5, which is hyperbolas. This is our last type of conic section. So, just like with all the other conic sections we've done, we're going to be able to write equations of hyperbolas and graph hyperbolas. Alright, so they compare hyperbolas to ellipses. We use the focus points again. We have different vertexes again, but we're not making a circular shape this time. They're two curves that are going out away from each other, either horizontally or vertically. So they do have some commonalities with the ellipses in terms of how their equation is set up, but the graph is very different. So we have our standard form here. We have a horizontal and a vertical. And again, it looks pretty similar to ellipses, except instead of a plus here, we have a minus. So that's the big difference between our equations for ellipses and hyperboles. And again, we use a lot of the same equations and relationships for our hyperbolas. So in the equation for any hyperbola, the value of 2a represents the constant difference. So that is the distance from the center to any point, or no, the distance all the way across from any point in your hyperbola from one side to the other. So we are going to look at a hyperbola and write our equation for it. The first thing we need to do is find our center. And our vertices are equidistant from our center. So I can see my vertices here at 0, 2 and 0, negative 2, and that would mean that my center is here at 0, 0. And then we need to find a. We have a and b squared that go at the bottoms of these fractions. That is the distance from the vertex to the center. So from either of these vertexes to our center is 2. And we need to find c, which is the distance from the focus to the center. And that distance, I can see the point here at 0, 4 and 0, negative 4. So the distance to the center is 4. And then we use this equation up here from the top of your paper about c squared equals a squared plus b squared. To find our b squared, which we need to go underneath our other fraction here. So we're going to plug in our values. We know that c is 4 and a is 2. And we're going to solve for b. So I'm going to subtract 4 from both sides. I get 12. Take the square root of both sides. So b is equal to square root 12. Now, I know that this is a vertical asymptote, And even though my lines are going in kind of a horizontal pattern, the line that cuts them both down the middle, the axis of symmetry in this case, for these hyperbolas, here is going to be vertical. So that's what makes it a vertical equation. So we are going to use the y squared over a squared minus x squared over b squared equals 1. So a lot like the ellipses equation, and remember, because this is at a 0, 0 center, we don't have to do that hk. It's just a standard y squared x squared. So we have our a is 2 squared, and our b is square root 12 squared here. And then we can simplify. Y squared over 4 minus x over 12 equals 1. So square root of 12 squared will cancel each other out and just leave you with 12. And we've written the equation for the hyperbola and the graph. All right, we are going to move on, and this time we're going to write the equation using the information they give us. They gave us some information about our asymptotes and our vertices. So we have vertices at 0, 2, -10, and 0, -2, square root 10, and we're going to write our equation based on this information. So the first thing we need to do is find our center. And they tell you that it's vertical, and I've got this distance here. We're going from 2 square root 10 to -2 square root 10. That's even distance. Our center is 0, 0 again, like it was with the last equation. And now we're going to find a and b. A is that distance from vertex to center, and they give me that here. It's 2 square root 10. And this time we're going to use our asymptotes to find b. And if I look back, I have this equation for my asymptotes here that says that my asymptotes are equal to b over a times by x. So the equation for asymptotes is y equals b over ax, and this tells me that my asymptotes are 3x and -3x, and since we're finding positive values, distance values, I'm going to use 3x rather than -3x to solve my equation. So I have 3x is equal to b over a to the x, and I also know a, so I can plug that in. 3x equals b over 2 square root 10x. So we're going to divide both sides by x to get rid of that. And when I do that, the x's will cancel out, and I'm just left with 3 over here. And then we're going to multiply both sides by 2 square root 10 to get b by itself. So I have 3 times by 2 square root 10, which gives me b equals 6 square root 10. So now I have an a, I have a b. This is a standard form of my equation, and I can just plug the information into this form. So we have y squared equals 2 times square root 10 squared minus x squared 6 times square root 10 squared equals 1. So we're going to get y squared over 40 minus x squared over 60 equals 1. All right, last question we're going to look at is graphing a hyperbola. They give us an equation to graph, so we don't have to find an equation. We're going to start by finding our center. That is equal to HK, and it's going to be, in this case, H here is with X, K here is with 5. So I have positive 3, negative 5, because remember these are both minus values when we do them as centers. So this one is fine because it's already minus, and this one we had to change. So I'm going to go ahead and plot that point, 3, negative 5. Hopefully you can see this all okay. And then I'm going to find my distance for my vertices using a. And a in my equation here, a squared, is 4. So a is 2. So that means that my vertices are 2 units from my center. And I know from the information I have already from how my equation is set up that this is going to be a horizontal hyperbola. So I'm going to plot my 2 points here. So I have one at 1, negative 5, and one at 5, negative 5. Those are my vertices. And that's kind of the spot that our hyperbolas extend out in either direction from. And then I'm going to find my foci it asked for in our equation. So the foci are equal to C. So if I find C in my equation, C squared equals A squared plus B squared. Yes. So we have 4 and 9 squared for that. So I have C squared equals, these are already in square form. So I have 4 and 9. So if C squared equals 13, so C equals square root 13. So this is A squared and B squared from here in our equation. So that's where that information came from. So now I know what C is, and my foci are (3 plus square root 13, 5, and 3 minus square root 13, negative 5. Those are both negative 5. And that equation is here, h plus c. So we found c, and h is from this center here, 3, so that's why I use that number. So h plus or minus c is your foci. And the last thing that we're asked to find is our asymptotes. And we use the equation, which again is back here, y minus k equals plus or minus b over a x minus h. So I have y minus k equals plus or minus b over a x minus h. So I'm going to plug in all the information that I have. Y minus negative 5 plus or minus equals plus or minus. And remember that the values we have here are b squared and a squared. So just b is going to be 3 and just a is going to be 2. And then we have x minus 3, which is h from our center. So I have y plus 5 equals positive 3/2 x minus 3. And I have y plus 5 equals negative 3/2 x minus 3. So here we have some point slope form equations, and I'm going to convert them really quick so that you don't have to. So I have y equals 3/2 x minus 9.5, and y equals negative 3/2 x minus 1/2. So I'm going to find those points. We're going to have a y-intercept at negative 1/2. And we're going to go down 3 and over 2. 2, 3. So there is one asymptote, and then we're going to have the other one is at negative 9.5. So down here, and we're going to go up 3 over 2. So 1, 2, 3 over 2. And you can see that both of these cross right through our center line. They're supposed to. All right, so there is something kind of defining which way our curves are going to go. So from here, I just used Desmos to kind of give me a better grasp on where my curves were going. And I had like a curve coming through almost here around 2. And then coming through here around 8. So this is the vertice. It's going to touch that. And kind of comes close to these asymptotes, but is never going to touch them. There's a really sloppy line, but you get the idea. And the other one does pretty much the same thing, and it looks like it crosses right through here at about 7 or 8. So we just kind of curve around, getting closer and closer to our asymptotes, but not touching it, with the bend being that vertice point. And that is how we graph a hyperbola.